All right, ladies and gentlemen, welcome to a brand new unit. We're diving into probabilities now. Taking that geometry stuff, kind of putting it off to the side, and getting back to like just number things again. So normally in your previous years, at this point, you do a lot of stats stuff, but probability is what you have this year. Probability and statistics are very closely related. Like when you want to figure out what the weather is going to be tomorrow, that's a probability based on a lot of statistics that been brought forth. And these are incredibly useful in making wise decisions. If the probability of failure is really high, you may not want to make that choice unless the gain's like really high. Things like that. And so it's really important for making decisions, which is why you get to learn about it. Our first lesson here is a lot of vocab words you need to know. And so let's dive in, and you can kind of see the vocab and some of these notation things that deal with probabilities. So our first vocab term is event. An event is some sort of activity, usually represented by a letter. Possible events, you're going to see is a whole lot, like picking a card from a deck, rolling a die, flipping a coin. Those sort of things are events. We're going to be kind of sticking with those as our themes, because those probabilities are really easy to understand. More complex things in real life get a lot more complex, but they're kind of based on these basic ideas. A sample space is the possible outcomes for that event. So let's say you're rolling a die. Your possible outcomes are 1, 2, 3, 4, 5, 6. A subset is a smaller set of those numbers. So a possible subset for rolling a die would be like rolling an odd number, which would be 1, 3, and 5. A complement of a subset is the things not in that subset. So let's say we're rolling a die and we're looking at a subset of odds. That's 1, 3, and 5. A complement of that would be the evens, the other numbers, 2, 4, and 6. And then there's some notation with complement. You can write not the subset, or scriggle that subset number, or the letter with a C on it. I tend to do the C to stand for complement, meaning not those things. So we're going to write out some answers here so you can kind of see what these look like. So let's say we're rolling a die. On a roll, you have some options. You can roll a 1, 2, 3, 4, 5, or 6. And when we write these down, we put them in these squiggle brackets. It's because it's a set, and that's set notation. A possible subset, let's say we're looking at odds. And usually if we're going with odds, we're just going to put an O. We tend to do just a single letter to represent things here. And our odds would be 1, 3, and 5. And then the odds complement would be the not odds, as in the evens, which would be 2, 4, and 6. So let's see if you can fill in this next row. You got pick a digit here. And then for our possible subset, let's go with the evens this time. And go ahead and write down what the subset for evens would be. And then write down the evens complement, and we'll go from there. So pause the video, write those down real quick, and see if you got them right. Alright, let's have you check and see how you did. On your first box, you should have written every digit 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. On the evens one, you should have 0, 2, 4, 6, 8. And on the evens complement, you should have 1, 3, 5, 7, 9. So there you go. Our next thing is some additional vocab. Sorry, moving on to the next part. Additional vocab. So this is where we start combining sets in different ways. So a union of two sets are the things that are in both of them. Something that's in either of the two events. Say your... We'll get to some examples later. Sorry. And the symbol we use to represent this is a U. You can kind of think this is or. And then the other option is an intersection, which we can think of as and. This is you want things that are in both events to be there. On the union one, you want something that's in either of the two. And so if I were to figure out A A union B, you'd be looking at anything that's in either of these two. You don't have to put any repeats on sets, but one of them, at least one of them has a 2, a 0, a 2, a 4, a 5, an 8, a 10, a 15, and a 20. So, and that just comes from looking through this list and finding all the numbers that's in either of those. Sometimes there's repeats like the 0s and the 5s and the 10s, but you don't have to put repeats. And let's see if you can figure out the intersection between A and B here. And those are the numbers that are in both. Has to be in both, which I kind of just told you. And go ahead and write down what that set is going to be. Pause the video. So there you go. It's 0, 5, and 10 is in both of those. And so yeah, the intersection is something that's in both. The union is, if it's in either of them, it's part of your set there. Over here, we're going to draw some Venn diagrams, just so you can kind of see things visually. And in case you've never done Venn diagrams before, you got two overlapping circles. You got event A, event B, and in the middle is going to be the intersection between them, A and B, and those are the numbers that are in both. And then on the outside here are things in A but not B, and this section is going to have things in B but not A. So we're going to write out things that are in A but not B would include 2, 4, and 8. And then over here, the things in B that aren't in A would include 15 and 20. And then the numbers inside here are the things that are in both, which include 0, 5, and 10. And then down here, it's going to be the same because they're the same two sets there. But we're going to write them both down, and then we're going to add some colors so you can kind of see what these represent in the Venn diagrams. And I'm going to see if I can get this highlighter. Yeah, highlighter. Hey, highlighter's working, I guess. Let's change color. Oh, hold on. I'm going to make it green. Because green's a color, I guess. If it will let me make it green. That's a terrible color. Why would I do that? All right. Anyway, on the top here, the part visually that shows a union of the two is just everything. Something that's in everything. Whereas the intersection of two subsets is actually just the middle part there. So my highlighter completely covered the numbers, but hopefully that gives you a visual representation of the difference between union and intersection. Union is everything. Intersection is just the overlapping part in the middle. So we got some more vocab terms at the bottom. I know you just love your vocab terms. The next thing is a probability. The probability is what's the likelihood that something's going to happen. You can write it as a fraction or as a percent. That's going to be kind of normal for us. I'll tend to do both. But we also going to write it as a decimal. And the number is always between 0 and 1. You can't have a probability that's more than 100% likely that's going to happen. You can't have a probability that's less than 0. Those are just exaggerations, even though people say it all the time. Independent events is going to be a theme of this unit. You're going to hear that a lot. It's going to be in a lot of our problems that we do. And then we got dependent events. Again, we'll get into more of that later. And then the joint probability is the likelihood of 2 or more events happening at the same time. These ones here we're going to get a lot more into in future lessons. But yeah, probability is going to be something you're going to do a whole lot. Like, what's the probability of this, probability of that? And it's just likelihood that something's going to happen over, the possible outcomes. Which, if you go to your next part, has that probability. A lovely little formula. If you don't got the probability of something happening, you put how many times the thing you want happens on top of your fraction. On bottom, you put the possible outcomes. Number of possible outcomes. Like if you're flipping a coin. Well, there's 2 different options, and if you want it to be heads, you put a 1. And here's a bit of notation there. The P stands for probability, and then the probability of some sort of event, like heads happening, You put that in parentheses, it's like a function. But if you want the probability of you draw a picture and the probability that it's a shark, it could be a probability. A little bit hard to determine, but yeah, it's there. You can roll a die and say, what's the probability of it being odd? And that's a probability you can get. So that's kind of how the notation there works. If you have a joint probability, you're going to get the probability of both of those things happening. Let's say you're flipping a coin and rolling a die, and you want the probability of getting heads on that coin and rolling a 5 on the coin. Well, you need to get the probability of heads, and you'll need it times by the probability of getting a 5, which the probability of getting heads is half, and the probability of getting 5 is 1/6 when you're rolling a die. And if you combine those, you're going to get 1/12. So if you were to flip a coin and roll a die, 1/12 of the time, you'll get a heads on the coin and then a 5 on the die. The next part here is the addition rule. The addition rule is if you want the probability of some event A or B happening, you are going to get those individual probabilities and add them up, but you also have to subtract off what's the probability of both happening, which is a little strange, but it's required, or otherwise you're counting something too many times. So let's look at this example over here. You're going to have some things like this on your assignment, so let's try this out. Let's say we have two different events. You're going to pick a letter from the alphabet, and you want to know if the letter is going to be in the word algebra or the word geometry, because, math words are important words. You'll want to pick letters from an alphabet. Don't worry about think too hard about the situation. Anyway, so you're trying to compute the probability of getting a letter that's in the word algebra or the word geometry. Well, to get that, you first need to get the probability of getting a letter from the word algebra, get the probability of getting a letter from the word geometry, and you have to get the probability of getting the letter that's in both of them and subtract that off. So we're going to take this one at a time. We got probability of algebra, which look through your letters here and count how many there are, how many unique letters, and put that over 26. And then you'll need to get the probability of getting picking a letter from the word geometry. And we're going to assume word capitalized and lowercase are the same thing. So, yeah, I'm going to keep that there. So look through the letters of geometry and count how many there are. Remember, you can't do repeats. So just because E shows up twice doesn't mean you count E twice. And so you're looking for a number of unique letters. So go ahead and get both of those real quick. Alright, should have gotten 6 out of 26 for the probability of algebra, and for the probability of geometry, should have gotten 7 out of 26. Again, the A's repeat, so you don't count those, and then the E's repeat, so don't count the second one. We also need to get the probability of algebra and geometry, so A and B. So you'll look through your letters here and see how many are the same. Look, we got the G matching, E matching. Let's see what else. Oh, R's match. So we got 3 letters out of the entire alphabet that match both. And so our probability here is going to be probability of algebra plus probability of geometry minus the probability of getting something that's in both. And that's going to give you, see, 6 plus 7 is 13 minus 3 gives you 10. So it's 10 out of 26. And 10 out of 26 reduces a little bit to give you 5/13. And ta-da, there's some notes for you.